What is AI? Most people, when they hear the phrase artificial intelligence, they think of something like Terminator or C-3PO, essentially machines that can think and act like humans. These science fiction associations are pretty useful for people who are trying to sell you or market AI products, but what is hype and what is reality? My name is Dr. Hiram Ring. I'm a linguist working at the intersection of anthropology, psychology, and computers. And I've started this series to help people kind of make sense of AI and filter out some of the noise that surrounds artificial intelligence in its current state. So, if you enjoy this content, please like, subscribe, share it, and if you have questions or comments or feedback, please leave those in the comments below. So to understand current AI systems, I find it helpful to use a different phrase for the acronym AI, and that is automated inference. The reason here is that the primary thing to be aware of with current systems is that while they're artificial, they're pretty far from intelligent. Let me explain what I mean. Artificial here refers to things that are manufactured or built, yet mimic forms in nature. So things like artificial rocks, prosthetics, plastic plants, etc. Intelligence in that phrase refers to an ability to process information, but this is where it gets a bit tricky because most AI researchers don't actually define the term. And for those that do, there's a bit of a debate about what constitutes intelligence. So, is intelligence simply the ability to regurgitate information? In which case, if you have a dictionary or an encyclopedia or a computer system that makes use of those, that could be considered intelligent. But for most people, that's not quite enough. And this is why Turing developed his famous test to determine whether computers can be deemed to be intelligent. So simply having access to information is not quite enough. It has to be processed or reasoned over in some way. Another consideration here is that there's differing degrees of intelligence. So animals can process lots of information to achieve particular goals, which are primarily related to survival, but they may accomplish some of these tasks better than others, and some animals may do this better than other animals. The kind of working definition here that most AI researchers have seemed to adopted in light of all these things is that intelligence is actually related to being able to accomplish tasks that humans are quite good at. And all of these tasks that have been proposed seem to share a pretty important skill, which is the ability to make inferences in new or novel situations. And this is what some people might call problem solving, using existing knowledge and applying it to a particular problem to find a solution. So while current AI systems fall pretty far short of humans in most respects here, this is what seems to be the goal of many AI practitioners. And so this is why I would suggest a better set of words to represent the acronym AI is automated inference. And automated inference is essentially what current AI systems like ChatGPT are doing. They're inferring an optimal solution from a set of data based on their observations of similar solutions from similar data. And this used to be called pattern recognition. It's been instrumental in developing all sorts of automated tools over the past decades. So the technology that underlies your speech transcription software, or the facial recognition that lets you unlock your iPhone. You can think of modern AI as a continuation of this progress of automation. So from the printing press, many, many years ago, to the cotton gin a few centuries later, and factories in the current era. So the big difference here between those automations and modern AI systems is really just the complexity of the patterns that are being automated, or the things that are being automated. And in the last few years, we've seen the development of systems that use language in much more human-like ways. Now, because there's such complexity in these systems, to handle that, modern systems have had to use something called machine learning. Essentially, machine learning is where computers identify patterns in a dataset using statistics and then correlate those patterns with particular outcomes that practitioners or developers are interested in. And this kind of complexity requires a lot of computational power. As computers have gotten more powerful in the last decade or two, it's allowed machine learning to scale as well and allow for the automation of incredibly complex tasks that people thought were impossible to manage. But this, of course, has its own challenges, which I'll try to cover in another part of this series. But for now, it's important to understand that current AI is definitely artificial, but whether it's intelligent depends on a pretty limited definition of intelligence. And so it might be better described in its current state as automated inference, using machine learning to do pattern recognition on large data sets and correlate those patterns with particular outcomes, allowing for the automation of incredibly complex tasks. This is kind of the magic of machine learning and modern systems, is that the complexity of the tasks make you think that it's actually intelligent. But it's really just automation. So in the next part of this series, I'll explore the idea of machine learning a bit more, looking at some of the similarities and differences between how humans and computers learn and do inference, as well as some of the challenges that this poses for modern AI systems. Thank you very much for watching. Do like and subscribe, and I hope to see you soon.